Alright, what is going on, Algebra Bros? In this video, we're going to find the real zeros of the polynomial function. Let's start out by setting f of x equal to 0, turning this into an equation that we're going to solve. X cubed minus 10x squared plus 28x minus 16 equals 0. Now let's form the list for p over q. The list for p will come from divisors of 16 or negative 16. It doesn't matter how you look at it. And then the list for q will come from the leading coefficient 1. So divisors of 16, including the negatives, plus or minus 1, 2, 4, 8, and 16. Divisors of 1, plus or minus 1. So the potential rational zeros will be plus or minus 1 over 1, plus or minus 2 over 1, and so on and so forth. And you'll notice that this is the same list as p, just in fraction format, which that tends to happen every so often. So if there are any rational zeros of this polynomial function, they're only going to come from this list. Now with that, there's way more fractions than zeros. So we're going to have to graph our polynomial function in the graphing calculator as y1 equals x cubed minus 10x squared, so on and so forth. And by graphing the polynomial in the graphing calculator, we can make an educated guess as to which one of those fractions might be a 0. Alright. So I'll go to y equals, type in x cubed minus 10x squared plus 28x minus 16. I'll do a zoom 6. And it looks like this function will have 3 real zeros. It looks like x equals positive 1 might be a real 0. Let me sketch out the graph. And I'm just guessing this 1, which by the way 1 does come from our list, so this seems like a candidate, but let's be sure of it with synthetic division. Alright, so I'm going to do the synthetic division real quick. Oh man, we get a remainder of 3. So it turns out that 1 is not a real 0. So let's go back to our graph. It looks like maybe 4 is another x-intercept. And 4 does come from our list. Okay, it's part of this set of fractions. So let's put 4 in the synthetic division. Check. Okay, we'll whiz through the synthetic division. I'm sorry, that's 16. Going a little too fast, I think. And boom! There we have it. 4 is one of our real zeros. So at this point, we can begin to factor the polynomial function f of x, and one of the factors is going to be x minus 4, and the other factor will consist of a quotient polynomial with these coefficients. Now we started out with a degree 3 polynomial, so this means that these numbers go for a degree 2 quotient polynomial, specifically x squared minus 6x plus 4. So at this point, our equation can be rewritten with the left-hand side being this partially factored version of f of x. And as it says on one of the pages of the notes for this section, once you have a quotient polynomial that's degree 2, or in other words quadratic, in which case we do, we set each factor to 0 to continue solving for x. Alright, by solving the first equation, we get confirmation that 4 is a real 0, kind of a double confirmation, if you will. And with the quadratic expression, if this factors by hand, then that'll be the quickest way of solving for x, but it doesn't look like it will because there are no factors of 4 that add up to negative 6. So for a situation like this, we're going to use the quadratic formula. Alright, let's simplify this bad boy. So 6 plus or minus. Now, that's going to be 36 minus 16, so that's the square root of 20. And the square root of 20 breaks down as 2 square roots of 5. And what you can do is divide the 2 in the denominator to reduce the 6 and the 2 that's in front of radical 5. And when you do so, you get x equals 3 plus or minus the square root of 5. So these are 2 additional zeros. Now we'll learn in the next section that a polynomial will have exactly n zeros when we start to consider duplicate zeros and or non-real zeros. Alright, so it'll never have more than the degree in terms of number of zeros. So the fact that we have a degree 3 polynomial and we're getting 3 solutions, or 3 zeros, means that we don't have to look for any more. So to wrap this up, I'm going to make a list of the zeros over to the left. It's where my most real, it's where I have the most real estate currently. We have 4, 3 minus the square root of 5, and 3 plus the square root of 5. And I'm also going to provide a factored form, or double F. Keep in mind the zero factor table. When we create a factor, it's always x minus the 0. So it's going to be x minus 4. And then I'm going to use brackets because the other 2 zeros have 2 terms. And I'm going to go a little bit further to distribute the minus sign to clear parentheses inside these brackets, thereby allowing me to rewrite the brackets as parentheses. So x minus 3 plus the square root of 5, and then x minus 3 minus the square root of 5. Okay, so there are the zeros, and if it had requested a factored form, okay, this would be the version to use. And there are the zeros one more time. Alright folks, that's it for the pain and torture. I'm sorry, fun and excitement. Of course, if you have any questions, feel free to let me know. Otherwise, thanks for watching, and I'll see you in the next one.